Hello students, welcome to the askIITians. I am Vijay Mukati, associated with askIITians. I have done my post-graduation from IIT Patna. I have also received silver medal in Communication Systems Engineering from IIT Patna. In this video lecture, I am going to explain you about communication systems. The word communication system itself gives you an idea about different applications of communication systems. The different applications include mobile communication, satellite communication, landline, fax, pager and many more. And so we will be going to study how and communication systems work. And therefore I have divided this chapter into different parts. In the first part, we will be starting with the introduction of an communication systems. In this part, I will explain you what are the different elements of an communication systems and how it works. Okay, so let's start with this first part. Okay students, so now we are going to start the lecture on communication systems. First of all, these are the topics which I will be going to cover in this lecture. First, I will give the introduction of communication system. Then we will discuss about communication channel. Then we will discuss about modulation and its needs, why the modulation is required. Then we will discuss amplitude and the frequency modulation. At last, we will discuss some IIT-JEE questions. Fine. Let's start with the introduction. What is communication system? So, a communication system is the setup used in the transmission of information from one place to another. So whenever we say that the information we have to send from one place to another, okay, that means the communication system is there. Okay, let's suppose if I am talking with any people, any one of you, okay, so that means we are communicating. That means the exchange of information. Exchange of information is a communication, okay, and the system, communication systems will have the all the units which are required for the communication to be successful. Okay, so the present day communication systems are like electrical, they can be electrical systems, they can be electronic systems, even they can be optical systems. Okay, you might have heard that right now the optical signals, optical cables are being laid out, okay, to transmit the data from one place to another, right? So that is a part of a communication channel. Okay, so the signals may be of any of the form. It can be electrical signal, it can be electronic signal, okay, or system, and also it can be optical in nature. Okay, now whenever we talk about the communication systems, we have to just whenever we talk about the communication systems, so we see that it basically consists of three main important elements. Okay, so elements are basically these three. One is the transmitter, other one is the communication channel, and third one is the receiver. These are the three most important elements of a communication systems. Without any one of these three, the communication cannot be possible. Okay, if we take this, look up this example here in this image. This is basically an example of satellite communication. So the two antennas are used, okay, ground antennas, and this is satellite, okay, and this antennas are used for the transmission and the reception. So if you see, the transmitter is basically a device which is sending the information. Okay, so in this case, if you see this first one, this antenna is sending the data to the satellite, right? And the receiving antenna is this one. Okay, the antenna which is on this side. So this is receiving the information from the satellite. So the transmitter and receiver are required. Other than this, the channel is also very important. Okay, the channel through which we are sending our information. Okay, it can be also, we will discuss about the different channel, but if you see in this case, so it's a free space, right? So we are actually sending this information in free space. We are not actually using any wires or guided wire line, right? We are sending here through a free space. So free space communication is taking place here, right? So transmitter, communication channel and the receiver, these are the three most important elements of any communication system. Let us understand the block diagram of a communication systems. So first thing is information source and input transducer. First of all, we should have an information source with us, right? Then a transmitter which will transmit our information okay, towards to the receiver end, right? The next thing with the next thing after the transmitter is channel. So whenever we are transmitting information, it will follow or it will go through a channel. There will be a channel through which our information will be passed. Okay, and this channel, this information will be passed to the receiver. So receiver will receive the information which is transmitted by the transmitter. Okay, but that will not be exactly same because the channel we are sending through channel, so there will be some modification in the signal. Okay, so we will see what modification basically it does, the channel does. After the receiver, we have the output transducer. So we will, in the next we will see the what are the basically the main purpose, okay, of all these blocks. We will study each of these blocks one by one. Let us start with the information source and input transducer. That is the first block. Okay, this is the first block of a communication system. That is the information source. Now the information which we want to send to a receiver, it may be an audio, it may be an image, it may be a text, it may be a data, right? Next is input transducer. Okay, transducer basically is a device which converts one form of energy into another form. So here we will be converting the source into electrical form because the source may be of audio, okay, image, data, text, or any form. But finally we want that the data should be converted into electrical form because our system is designed in such a way that it can handle the electrical signals only. Therefore, we require the input transducer. So it converts the signal into electrical form, right? Now, so if we see the example of this information source and the transducer. So examples of transducers are microphone. Microphone converts our voice signal into electrical signal. Camera, okay, our motion into electrical signal. Keyboard, okay, whatever we are typing, so it provides the text image form, text data. Okay, these are some examples of the input transducer. Next, let us see first of all what is output transducer. Okay, let us first focus on the output transducer. Now again, this is just a reverse process. Okay, this will be just do the reverse process as the input transducer does. Okay, so it will convert the electrical signal into usable form. Usable form means, let's suppose I am sending a voice, okay, to someone else, and first of all I will be converting, the system will be converting that signal into its electrical form, but the receiver cannot the person who wants to receive, okay, through whom I am sending my signal, will not understand the message in the electrical form. So he wants the message should be in the right audio or the voice. Okay, that voice should come. That means that function will be done by the output transducer. So output transducer will convert the electrical signal into usable form. If you see the examples, so its examples are speaker and monitor. If you see speaker converts the electrical signal into an audio signal. Same way monitor. Okay, this is also an output signal. So this basically converts the signals into usable form. Okay, in which the user can understand easily. Now let us see transmitter. What is the purpose of transmitter? So the input transducer is sending the electrical signal to transmitter. Now this electrical signals is again converted into suitable form for the channel. See, the information has to be passed through a channel. Okay, and whatever, so there has to be some specification, right? That it cannot be that all the channels can be passed, all the signals can be passed through a channel. So that electrical signal has to be converted into suitable form, okay, which can be easy, so that it can easily pass through the channel. Okay, we want that there should be minimum loss in the channel. So that for that purpose we are designing a transmitter in such a way that our efficient information can be passed through this channel and it should be received to the receiver. Okay, so if you see that it does the mainly two functions. Transmitter does the two functions. One is the modulator, the modulation. So it has modulator for the modulation purpose and the amplifier for the amplification purpose. What is modulation? That we will discuss, okay, in the coming parts. And what is amplifier? So amplifier is an electronic device which amplifies, okay, or it increases the strength of the signal, which is very much required, right? If we want to transmit the information from one place to another place, so the most important thing is we have to first of all increase its strength or its quality before sending it through the channel. Now let us see what is channel. So channel is a medium used to transfer signal from transmitter to receiver. So channel basically transfers the information from transmitter to receiver. Okay, it can be either a point to point or broadcast. Okay, the channel, so we can either do the point to point communication or we can broadcast the signal. So in case of broadcast, the transmitter is one but the receivers are multiple receivers. Okay, now the channels can be either a wire line, so that means a wire through which the information is passing on. It can be a fiber optical cable, so optical cable, fiber, okay, so fiber is lead in which optical signals are sent and it is being communicated. It can be an atmosphere, that is a free space. Okay, so even in the case of, let's example is mobile communication. In mobile communication, we are sending our signals in the atmosphere, that is in the free space. Okay, now basically the channel often adds noise or weakens or distortion the signal. Okay, so this is the block where the information or you can say the information distorts or weakens because the noise is added up. Okay, so the noise is also adding here in the channel. Okay, so therefore the receiver will not get the exact information which we are sending from the transmitter. So if you see the receiver, so receiver basically extracts the or estimate of does an estimate of an original transducer output. Okay, that means the receiver receives the signal from the channel and it tries to estimate what the transmitter has transmitted. Okay, or we can say what input transducer has transmitted. So basically the output of receiver should be ideally equal to what the input transducer is sending. So this information should be ideally equal. If our system is purely perfect and pure, no any noise, not any distortion, then this signal transmitted by the input transducer will be exactly same as the output of the receiver, right? Because receiver will estimate what the input transducer has sent. Okay, now it has also a demodulator, that is the reverse process of modulation. So modulator, and here we are having in the receiver as a demodulator. It will demodulate the signal. After this, we also have an amplifier because the signal should be, the signal will be sent to the user. Okay, and the user wants this quality again in the good quality, right? The quality should be good for the receiver also. The user also. Therefore, one more way to, the amplification is also done in the receiver part. Fine. So all these are the block diagram of the communication systems. Okay, let us see an example. Okay, that will give us some more knowledge about this system or a block diagram. Okay, so the maximum range of a transmitter depends on its frequency, its power, both its frequency and power, none of the above. Okay, so we actually are asked that what is the parameter on which the transmission range depends. Okay, so maximum range of a transmitter will depend on either frequency or power or both or none of this, right? First of all, see, power is obvious. If you think logically, more power if you will be sending and more power, so it will reach the information to a more distance. Let's suppose if I'm speaking. Okay, so if I will speak loudly, so my voice will reach up to a larger distance. That means if I will give a more input power, so the distance of communication will increase. That means the power increases, the maximum range also increases. Second thing, frequency. So we will see in the other parts that frequency is also a factor on which the transmission range depends, and it is an inverse. Okay, so range is inversely proportional to the frequency. That means the frequency increases, the range decreases, and the frequency decreases, the range increases. So that means we can say the range of a transmitter depends on both the frequency and the power. Fine. Let us move on to another example. In a color TV receiver, the bandwidth of an RF amplifier is. So basically we are asked that in case of TV receiver, the bandwidth of amplifier, RF amplifier, that is a radio frequency amplifier, is exactly equal to channel width, little less than channel width, little more than channel width, either A or B. So basically the question is, so we have seen that we are having a transmitter, we are having a channel, and we are having a receiver. Okay, so that receiver will receive the signal from the channel. Okay, now what should be the bandwidth of an RF amplifier? It should be equal to an channel width, it should be less than channel width, more than channel width. Okay, so first of all, it cannot be less than channel width, because if we will decrease the bandwidth, okay, if the bandwidth will decrease, so we will not be able to get all the information sended by the transmitter or the channel. So therefore, it cannot be less than. Now if we will keep exactly equal, so that will be fine in case of our system is ideal. Okay, all the components we are using are ideal. Okay, and also the channel is ideal. All these things we assume as an ideal case. But we know that the ideal case is not possible in the practical world, right? Therefore, the bandwidth should be little more than the channel width, right? Therefore, the bandwidth of an RF amplifier should be greater than or equal to channel width. So more appropriate answer would be option C. Okay. Hello students. So in this part we have studied the different elements of communication systems. We have seen the working of transmitter, communication channel and receiver in detail. In the next part we will be studying about communication channel in depth. So stay tuned with us.